So here in this video I'm going to talk about fluids. You may be wondering, why you can see only probably this part of my hand, not other, rest of the part of me. The reason is I just thought, since you need to really pay attention to the board, so instead of just having me blocking this whole board, I thought I would just video record the part that's the most important. Okay, all right. So where shall we start? So let's talk about fluids. So what do you think fluid is? Have you heard about the term fluid before? When was the last time you have heard about fluid? Or when was the last time you used fluid? Maybe, you drank a tea, you drank water, maybe Coke, or you took a shower, or you were just sitting in the room, where there is some air. So all of those are actually example of fluids. So if we want to define fluid, then what we could say is a fluid is a substance. This is just a substance that flows. Mainly there are two types of fluids. One is labeled as gases, another is labeled as liquids. So both of these gases and liquids, both of these are considered fluid. Both of these have property of flowing. Okay, now let us see. I want to show you guys picture here. Do you guys see here? Right here. Okay, so I have the liquid here of different color. All of these are fluid. So you guys already know typical example of liquid, right? Like as I mentioned earlier, and then you have also, you have also seen them in your day-to-day life. You may be surprised. I'm gonna tell you this. You may be surprised. I don't know. Let's see. Glass is actually a liquid. So this is here. It's a picture of the glass. It's considered as a liquid. So when we are talking about fluid, we are talking about some matter, right? Matter in the universe. If we really want to distinguish, let's say fluid, or let's say the matter such as gas, liquid from solid, then one of the pictures we can use is something like this here. So maybe I will just wipe this one here and let's see. So for solid, let's look at this picture here. This is one model. Solid, the atoms are very, very close to each other. Liquid, they are close to each other, very close. There is really barely little space. Gas, the atoms are far away, right? So what does this really tell us? Solid, it's very rigid here, right? We cannot compress these atoms anymore, or even molecules. And then for liquids, again, we cannot compress it, but however, if we kind of squeeze it, I think what can happen is they can kind of move it around. Okay, but again, liquid is not compressible. You cannot compress it, right? So gas, however, see, there is an empty space between these atoms here, And then what you could do is you can actually squeeze this, so you can change the separation between these molecules. Okay, so that is the differences between solid, liquid, and gas. Solid, you cannot compress, right? Incompressible without deforming it. That's important. Liquid, incompressible. Gas, we can compress it. So now we want to talk about one of the quantity, which is a characteristics of the material. This is called density. Density, it is represented by Greek letter rho. Have you guys heard about this quantity before? Yes? No? So what is this really density? Density rho is given as the ratio of mass to volume. Okay, so I'm gonna just write here rho equal to mass. Let's represent as m by volume. Okay, so ratio of this is ratio of mass to volume. It has a unit. Have you guys learned about how to find the unit of the substance of a quantity? I hope you guys are already familiar with. So let's see, what we could do is to find the unit of this quantity, we can just say, let's do this unit mass. What's the unit of this guy here? This is measured in kilogram. This is measured in what? Meter cube. So unit should be just kilogram, this same sign, per meter cube. Okay, so that's the unit. This arrow means nothing here. Okay, I know in physics we have to be very precise, but this arrow, I'm just saying how you measure this, just to show the unit. Okay, so this is just unit is kg per meter cube. There are other common units, like other common units such as gram per centimeter cube. Another unit you could say gram per milliliter. And then there is also conversion factor for 1 gram per centimeter cube is equal to 1000 kg per meter cube. Okay, so this is something that will be helpful for conversion. Okay, do you have any question about density? Yes? No? So please take a moment to see if you understand what is here on the board and what I just said. So let us say, maybe I will just give you guys an example here. Can we find the density of this quantity here, this object here? What do you think we need to do if we want to find the density of this object here, this eraser here? So density is what? Rho equal to ratio of mass to volume. So if we have a measuring scale, we measure the mass of this in kilogram, and then we find what's the volume of this. It's pretty easy to find the volume, right? You can measure the length, you can measure this width, height, and then you can also measure the width here. So you can find the volume. Okay, so once we have that number, we can just find what's the density of this object here. So what is this? Is this, well, I said density of this object. Actually, density is characteristics of the material that the object is made up. Okay, so really to make what I just said more precise, what should we do is probably we don't want to consider this part. We want to find only density of this material here, okay, because this material will have a different density. See, this is made out of different material. So density is really density, it is a characteristics of the material. So it is what? Characteristics of the material that object is made up of and is independent of object size. Object size, okay, so it is an independent of the object size. So what does that mean? Let's say I had this, let's say, imagine we don't have this part here with this quantity, this object is made out of just this material here. We can find a density by finding the mass and then finding the volume, and we can take the ratio. But then we are also saying it is independent of object size. What does that mean? So let's say I have another eraser. Again, imagine that also does not have this part, we have only this part, and that's, let's say, that's probably like this big, this tall, maybe this wider, and then made out of the same material. Then both of these, this object and this other object that we just imagined, must have the same value of density. That's what it means, independent of object size, okay? This is very important. Any question here? If you have a question, please post it in the class discussion section. Okay, so I'm gonna show this here. Alright, so here I have density of fluids at 1 atmospheric pressure. We'll talk about what that means in a few minutes. Density of fluid, so we have various substances here, and then the density is given in kilogram per meter cube or cubic meter, however you want to say. When I learned this as kg per meter cube. You may have learned it kilogram per cubic meter. It doesn't matter, as long as you know what this means. Substance here, helium gas at 20 degrees Celsius, the density is 0.166. Do you guys know helium is also supposed to be very, very light, okay? Air, just like air in your room, maybe like, which is probably about 20 degrees Celsius, the density is 1.20 kilogram per meter cube. Air at 0 degrees Celsius is 1.28. So you see, when the temperature is smaller, the density is a little bit higher. You would know it. Do you know why this is the case here? What happens when the temperature goes down? The molecules could be going, they come closer, right? So volume would reduce, basically. A gasoline density is 680 kilogram per meter cube. Ethyl alcohol is 790 kilogram per meter cube. Oil, typical oil, is about 900 kg per meter cube. Water is 1000 kg per meter cube. These two here, I just want to point this out right now. Oil and water, they have a different density. When we mix, something should happen here. Something for you guys to just, I'm just pointing this out for you to make you, keep you curious, okay? They don't mix it to each other. See, their density is different here. Seawater is, the density of seawater is a little bit higher than the regular water here, so which is 1030. Blood, whole blood density is a little bit higher than the seawater, which is what, 1060 here for blood. Glycerin, 1260, it has a higher density. Mercury, very high, 13,600 kg per meter cube, okay? So mercury is very dense. Okay, so let's talk about another quantity we are interested. Another quantity is pressure. Pressure represented by P. Your textbook may have used lowercase p, but really, as long as it is consistent to the text, that's fine. Pressure P. What is this pressure? Have you heard about the word pressure? I imagine you have heard, blood pressure or something like that, right? So what does that really mean? So what happens, let's say, do you think I'm just pushing here? You guys already know the concept of the force. If we push here, do you think there is a pressure? What do you guys think? Try it yourself. So whatever you have with you right now, try it out. If you can put some pressure on anything around. Okay, so pressure is a ratio of force to unit area. Or really, two, you could also say, it's pressure is really force per unit area. So pressure, we can write here pressure P as force F by A. Okay, important thing here, for force per unit area. So what is this force really? What kind of force are we talking here? Is this force like, let's say if we imagine, let's say this surface here, are we talking about the force like, perpendicular, or I don't know, let's do this. I'm gonna use this tip. Okay, perpendicular to this surface, or it is parallel to this surface, or where is this force is applied? So when we talk about the pressure, for the case of pressure, this force is applied actually perpendicular to the area. Okay, so this pressure is a ratio of the force per unit area. Now you may think, okay, it's kind of, you're doing it on the board, how is it related to the fluid then? Okay, so imagine you have a cup of tea. Okay, then what happens if you have a tea? Actually there is a fluid, they are kind of pushing each other, right? They are kind of a fluid, the molecules, they can move in a fluid. So because the molecules can move, they are kind of, they can push pressure, they can push against the wall. So you could say that there is actually molecules pushing on the wall, also they are getting pushed. Okay, so you can also find that, so you see there is actually pressure on the fluid due to the force. Okay, but that force is perpendicular to the application of the perpendicular to the area. Okay, so here again, if I were to write, if I do this is not a pressure going like this, but if we apply like this, and then this, in this area the force is applied perpendicular, then that is a pressure. Okay, now it has a unit, so unit of pressure is what? Can you guys calculate, find this out? This force is measured in what? I hope you remember by now. Newton, right? And then this per sign, we can just write that here, and then area is measured in what? Meter squared. So Newton per meter square is the unit of pressure. This is also called Pascal, P-A-S-C-A-L, Pascal, and then represented as P, capital P, A. Okay, so Pascal, after the scientist Pascal, we'll talk about Pascal after some time. So this quantity pressure, it is a scalar quantity. Okay, so scalar quantity. And then always please again remember the direction of this force associated with the pressure is always perpendicular to the surface of interest. Okay, so that is important to note. Typical pressure is, about like, let us write this in. Typical pressure is about 10 to the power 5 Pascal. Do you think there are other common units for pressure? Have you heard anywhere any other units? Have you used any, anything that has to do with the pressure outside of home? Yes? No? Okay, let us see if you have used it or not. Okay, so I'm gonna erase this part. Alright, let's look at some other common units of pressure and where we use those. So here, unit is Pascal. Conversion to 1 atm is 1 atmospheric pressure. Okay, so 1 Pascal is really equal to 1.013 times 10 to the power 5 Pascal. Uses is SI unit. Okay, so we use SI unit. We are in physics, right? We use SI unit. Atmosphere, so again the atm is 1 atm is equal to 1 atm. This is just the conversion for the atmospheric pressure. Okay, why do we use this atmospheric pressure in general? Mm of Hg, this has to do with millimeter of Hg means mercury, millimeter of mercury. We'll also learn about this more as we get to something called barometer later in this lecture. So mm of Hg is equal to 760 mm of Hg. This value is same as 1 atmospheric pressure, and then this is used to measure barometric pressure. Inch Hg, that is equal to 29.92 in inches. So that's the conversion factor to 1 atm. Barometric pressure in US weather forecasting. This was something I was not familiar with that because I was not raised here, so I thought this was new for me, even for me. PSI, this is very interesting. PSI, so PSI is equal to 14.7 psi, gives you 1 atm, used in US engineering and industry. Do you guys know okay, have you guys ever had issue with your cars or your vehicle tires pressure? This is the quantity you usually use, okay, or this is the unit you usually refer to. So if you go to gas station and then you are trying to you check the tire pressure, and then you just realize that, or you got some notification that the pressure, you got to check the pressure, then you go and you put the pressure, and then you probably see, what's PSI, right? Per square inches. What's the pressure, right? And then you just put that, you pump the air on your tire, and then you read, I don't know, maybe like 32 psi or something like that. So that's mostly used in US engineering and industry. Another unit is bar. So bar is same as 1 atmospheric pressure. This is a British unit. There is another unit called torr. Torr is equal to 1 torr is equal to 760. That is also equal to 1 mm of Hg. Okay, 1 mm of Hg. So, and then this is used in vacuum systems. All right. So let us see what are the implications then, of this, this quantity or pressure, or where can we see it in real life? or maybe this is not just real life, this is a demo demo life. Okay, all right guys, so here is someone sitting on the bed of nails. Okay, how do you think this is possible? This person doesn't get hurt, and there is no, the nail doesn't poke any hole in the body. How is this possible? Take a moment to reflect on that, or to see how this is possible. So how is this even possible, right? How come this person doesn't get hurt, or the nail doesn't poke a hole? We just talk about, pressure is force per unit area. So when we talk about the pressure, actually what happens is, pressure we are talking about is, this pressure is what? Total force per unit area, right? Area. And then in this case what happens is, there is the force is applied from this person's body, and then the area is like, see, this area is, the tip of the nail is like so small, so that when you take that ratio, it just come out to be negligible. That's how this person comes out. Person can just sit on the bed of the nail and doesn't get hurt or cut. Okay. Oh, here is another example of this pressure. A perfect gift here, acupressure mat for relaxation and mindfulness. You see, this mat could be used for relaxation and mindfulness. All right, so let's see. This is a checkpoint question. Let's say you and some friends are ice skating on a frozen lake. A buddy of yours has fallen through the thin ice. Describe some different ways in which you might rescue him. Which might be the safest? So please, note down this question and then try to come up with the ways in which you might be able to rescue him. Alright, so that question is for you to think over, okay? So please think about this and then see if you can come up with a few ways. Okay, so now here is another question, conceptual question. You decide to, go to a swimming pool. How does the pressure changes as you go deeper in a swimming pool? What do you think would happen as you go down, in a swimming pool? Do you think pressure changes? Does pressure increase? If so, does pressure increase or decreases? And why do you think it? If it changes, why do you think it changes? If it doesn't change, why do you think it does not change? Alright, I hope you thought about something about these questions. Alright, so I have here this topic here about pressure and depth in a static fluid. It says done on the board. Actually, I have made a separate video of it, so I'm going to post that separately. Okay, so please watch the separate video related to this pressure and depth in a static fluid. I'll post it again on the course page. Okay, so let's take a break, short break, maybe for 2 minutes. I'm gonna pause this video and then start recording the other half of the video. Okay,